Windows NT wasn't really Windows. Although the familiar desktop was called NT, Windows was only one of the personalities it could assume. The same NT machine could provide an OS2 environment, a standards-compliant POSIX environment, all running above the same NT kernel. No emulation, no hypervisor, no dual boot. So why did Microsoft build an operating system that wasn't tied exclusively to Windows? And what became of the other operating systems hidden inside it? Windows NT began as a result of the partnership between Microsoft and IBM, which faced many challenges and eventually ended. By the late 1980s, IBM remained the dominant force in business computing, while Microsoft supplied the MS-DOS operating system used by millions of IBM-compatible PCs. However, DOS had important limitations. It was based on the original 16-bit architecture, didn't offer much memory protection, and could not support reliable multitasking for business users. The proposed solution was OS2. Jointly developed by IBM and Microsoft as the protected mode successor that would eventually replace DOS. But Microsoft was already considering what would come after OS2. The company saw that business computing was moving to 32-bit systems. It also recognised that Intel might not always be the standard. As a result, Microsoft wanted its next operating system to work on different processor types, support multiprocessing, and offer improved reliability and security. So Microsoft hired Dave Cutler in October 1988, and he led the project. Cutler had previously led the development of VMS at Digital Equipment Corporation. He brought several former DEC engineers with him and started designing a new operating system from scratch. Cutler was a skilled and demanding engineer, and he brought the same design priorities to Microsoft: reliability, security, virtual memory, and support for multiple processor architectures. Windows NT was later described as the successor to VMS. A well-known piece of computing folklore notes that if you shift each of the letters VMS forward by one in the alphabet, you get WNT. This is likely a coincidence, as there is little evidence this is how Windows NT was actually named. Initially, however, this secret new operating system was not intended to become Windows NT. The project was known as NT OS2 and remained closely connected to Microsoft's partnership with IBM. Its eventual purpose was to provide the technological foundation for OS2 version 3.0, a fully 32-bit portable operating system capable of running on several different processor architectures. OS2's applications were therefore expected to form its primary user environment, but Cutler's team did not build OS2 directly in the heart of the system. Instead, they designed a largely neutral operating system core with separate environmental subsystems, providing the interfaces expected by applications. That decision would later make it possible to replace OS2 as NT's main personality without abandoning the underlying operating system. Cutler aimed for NT to work independently of any one processor family. Most of the operating system was written in Portable C. The hardware-specific code was kept in separate, clearly defined layers. This approach was important because Microsoft did not know which processor architecture would become the standard in the coming years. Intel's x86 chips were still widely used, but NT was also built to run on newer, reduced instruction set computer processors like MIPS and later Digital's Alpha. The goal was ambitious. The same operating system needed to move between very different hardware platforms without being rewritten from scratch. Portability was not just a feature, it was one of NT's core principles. The direction of NT OS2 shifted after Microsoft released Windows 3.0 in May 1990. Earlier versions of Windows had struggled to gain traction, but Windows 3.0 saw strong commercial results. It provided a better graphical interface, worked reliably on the increasing number of 386-based PCs, and let users keep running their DOS apps. It also attracted customers and software developers in a way that OS2 had not. Microsoft could no longer treat Windows as a temporary step towards IBM's operating system. The PC market now seemed to favour Windows, so the NT project needed to adjust its direction. That success helped bring the already strained Microsoft-IBM partnership to an end. IBM continued developing OS2 alone, while Microsoft took control of Cutler's new operating system project. NT OS2 was gradually transformed into Windows NT, and its main application environment was changed from OS2 to a new 32-bit Windows interface, Win32. This was the crucial strategic pivot. Rather than asking developers and customers to abandon Windows for OS2, Microsoft could now offer a modern, secure operating system that still belonged to the rapidly expanding Windows software ecosystem. OS2 was not removed entirely, however. It survived inside NT as one of several compatibility subsystems. Despite the massive pivot, the architectural blueprint Cutler and his team had established allowed Windows NT to function as an OS chameleon. Microsoft felt legally, politically and commercially compelled to include a dedicated OS2 subsystem in the final release of Windows NT. This inclusion was a vital concession designed to support enterprise customers and corporate developers who had already invested millions of dollars transitioning from MS-DOS to OS 2.1 applications. The OS2 subsystem existed largely to preserve compatibility and reassure existing corporate clients. The POSIX subsystem, however, was included for a very different reason: access to the enormous United States government market. During the late 1980s, federal procurement policy increasingly favoured open, standardised computing environments rather than systems tied to one manufacturer. A particularly important requirement was FIPS 151-2, the federal standard based on the POSIX programming interface. For Microsoft, this created a simple commercial reality. Without a POSIX-compatible environment, Windows NT would be excluded from major federal and defence contracts before its technical merits were even considered. FIPS 151-2 was based on the IEEE POSIX.1 standard, which defined a common set of C-language programming interfaces derived from the Unix world. The purpose was portability. Software written to this standard could, at least in principle, be moved between compliant operating systems without being completely rewritten. For federal procurements that specified a POSIX environment, merely claiming compatibility was not enough. A system had to pass an official validation process demonstrating that it conformed to the standard. This gave Microsoft a powerful financial incentive to make Windows NT compliant from the beginning. POSIX support would allow NT to qualify for government workstation and server contracts that might otherwise remain open only to established Unix vendors. Microsoft did not design the original POSIX subsystem to make Windows NT a full Unix workstation. The main goal was to add just enough of the POSIX.1 interface to meet federal standards and qualify for the government contracts. The subsystem was very limited. It only included the basic C system calls needed for the standard. It did not have features like a full command shell, networking tools, or many common utilities found in Unix. Adding POSIX support helped Microsoft sell Windows NT into the federal market. It did not compete with Win32, which was still the main platform for customers and developers. To see how Windows NT could run programs from different systems, it helps to look at how its client-server setup works. NT was split into two main parts, user mode and kernel mode. Most programs ran in user mode, which meant they had limited access and couldn't reach the hardware or important parts of memory directly. The kernel and executive worked in kernel mode. Here, Windows NT handled memory, processes, security device drivers and hardware access. This split made NT more stable and secure. If a regular program crashed, it would usually not crash the whole system. This setup also allowed NT to support different types of application subsystems. Windows NT relied on the kernel and the executive to handle things like running programs, managing memory, keeping everything secure, dealing with the input and output and connecting to the hardware. Applications did not talk straight to NT's basic services. Instead, they used an environmental subsystem that made the system look and feel like the operating system they were built for. When a program started, its header told NT which subsystem it needed, like Win32, OS2 or POSIX. NT then ran the program in the right environment. Each subsystem acted like an interpreter. It gave the application the function it was looking for and turned its request into something NT could understand. Sometimes applications and subsystems used NT's fast local procedure call system called LPC to talk to each other. This meant programs from different parts of environments could use the same core parts of NT, like the kernel, memory manager, security and hardware drivers, while still feeling like they were running on their own operating system. This explains the meaning behind the title of the video. At its lowest levels, Windows NT was not inherently tied to the Windows programming environment. NT itself provided the common foundation, processes, memory management, security, input, output, and access to all the hardware. Win32 was the primary personality built on that foundation, but it wasn't the only one. The same underlying operating system could also present an OS2 environment or a POSIX environment to the applications written for those systems. In this way, Windows NT was not just another version of Windows, it was a neutral operating system platform that could support different environments, including Windows. The OS2 subsystem in Windows NT acted as a technical bridge to a future Microsoft chose not to pursue. It was mainly built to run 16-bit character mode applications from OS 2.1. Most of these were business programs that worked in a text-based session, not with the later graphical presentation manager. This limitation mattered. Windows NT did not include a full version of OS 2, so it couldn't run every OS 2 program. It kept just enough of the older OS2 environment to support a certain group of applications. For organisations using those programs, the subsystem gave them a way to move from OS2 to Windows NT without having to replace every application right away. The OS2 subsystem included several parts that worked together. When you launched an OS2 application, Windows NT loaded libraries like doscalls.dll and netappy.dll into the process. These libraries gave the program OS2 functions it needed and turned its requests into actions that NT could handle. The main OS2 subsystem process, os2ss.exe, kept track of the shared state and handled things like processes, sessions and communication with NT. Another part, os2srv.exe, helped set up and manage the OS2 application process. With these pieces working together, a real OS2 program could run in user mode and use NT for memory files, security and hardware. The application did not run full inside the OS2 system. Windows NT just recreated the OS2 services for the program that needed them. Windows NT could run on many types of hardware, but its OS2 subsystem only worked on the Intel x86 version. This was because the supported applications were made for OS 2.1 and depended on the 16-bit segmented memory system used by the Intel 80286 processor. These programs expected to use selectors and segments to access memory instead of the simpler flat memory layout found out in most 32-bit software. To make these programs work, the x86 version of NT had to use processor features like local descriptor tables. This let the OS2 subsystem set up the kind of memory environments those older applications needed. MIPS, Alpha and PowerPC systems did not have the same Intel hardware features, so while Windows NT could run on those processors, its 16-bit OS2 compatibility layer could not. By default, Windows NT's OS2 subsystem could only run character mode applications. If you wanted to use graphical programs made for OS2's presentation manager, you needed to install a separate Microsoft product called the Windows NT add-on subsystem for presentation manager. This add-on was not included with Windows NT by default, and Microsoft didn't promote it much either. After you installed it, the subsystem could run graphical applications made for the 16-bit OS 2.1 presentation manager, and using it wasn't a smooth experience. To run a graphical application, you had to start the PM shell first. This brought up a separate full-screen OS 2 style desktop with its own print manager and a button to go back to the Windows NT desktop. Graphical OS 2 applications ran inside this separate presentation manager environment, not alongside your regular Win32 Windows. It did work. I've set it up on Windows NT 4 myself, but I didn't feel like it really gave you true application compatibility. Instead, it was more like stepping away from the Windows desktop and into a leftover bit of OS 2. While the OS 2 subsystem was kept mainly for compatibility, the POSIX subsystem had a specific goal, meeting federal POSIX requirements so Windows NT could qualify for government contracts. Microsoft implemented only POSIX 0.1 interface requirements by the FIPS 151-2, adding little else. The goal was not to turn NT into a Unix workstation, but to provide just enough to meet the standard. The subsystem was divided by three principal components. PSX-DLL.dll provided the POSIX functions called by applications and translated them into operations understood by NT. PSXSS.exe was the central subsystem server maintaining the shared POSIX environment and managing its processes. Finally, POSIX.exe created the console session through which POSIX applications were launched and displayed their output. These components gave Windows NT a basic Unix-like programming environment, enough for official POSIX validation, but not meant to compete with Win32. NIST listed Windows NT 3.5's POSIX subsystem as validated under FIPS 151-2. Microsoft's first POSIX subsystem was limited because the POSIX.1 standard itself only covered a small set of features. It included the basic C interfaces for things like creating processes, working with files and setting permissions. However, it was never meant to be Unix. There were no support for network programming with Berkeley sockets, no X-Windows system for graphics, and none of the usual Unix shells, compilers or command tools. The only major tool included was PAX, a basic program for creating and reading portable archive files. So while Windows NT technically met the POSIX requirements, it didn't feel like a typical Unix workstation. The subsystem was really just an interface for running certain software, not a fully operating system. FAT came from MS-DOS and was still common in Windows 95, but it didn't meet the needs of a Unix-style system. It was missing features that POSIX programs usually need: hard links, case-sensitive file names, and more detailed file stamps. NTFS was not made just to add POSIX support to Windows NT. Microsoft also wanted a modern file system that offered better security, reliability, recovery options, and could handle much bigger disks than FAT. Still, POSIX compatibility was a key part of NTFS's design. From the start, NTFS included features needed by Unix-style software so it could work with Win32, OS2 and POSIX programs. So while POSIX was not the main reason for NTFS, it did help shape some of the features that set NTFS apart from FAT. Three particular NTFS capabilities were especially important to the POSIX subsystem. The first was case-sensitive naming. Win32 saw readme.txt and readme.txt as the same file. NTFS could tell them apart by capitalization, so POSIX applications could use them as separate files. The second was support for hard links. 2 or more directory entries could point to the same file. If you deleted one name, the data stayed on as long as the other hard link remained. Finally, NTFS kept more types of timestamps than FAT. It recorded when a file was created, access changed, and when its metadata changed. These features were not made just for POSIX, but POSIX compatibility made sure they were part of the NTFS file system. POSIX Subsystem found it especially hard to reproduce the fork system call from Unix. In Unix, fork makes a child process that's almost the same as its parent. The child gets the parent's memory, open files and execution state. Both processes keep running from the same place in the program. Modern Unix systems do not copy all memory right away. They use copy on write, so the parent and child share memory pages until one of them tries to change something. Windows NT used a different process model. Win32 applications usually called create process, which made a new process and loaded a new program from disk. There was no direct way to duplicate a running process. The POSIX subsystem had to use NT's lower level process and memory tools to copy fork's behavior. It needed to make the child rebuild the parent state and then make sure both kept running from the right place. This made fork one of the hardest features to implement. By the late 1990s, OS2 had lost its place in the commercial market. Most software vendors had switched to the Win32 API, so 16-bit OS2 applications were no longer useful. And as a result, Microsoft removed the OS2 subsystem when Windows 2000 was released. When Windows 2000 was released, the OS2 subsystem was already a legacy feature. It still came with the operating system, and files like OS2exe, OS2ss.exe and OS2srv.exe stayed in the System32 directory with backup copies in the DLL cache. The subsystem only ran when an OS2 application needed it. For most users, it was extra code that served no purpose. Security guidelines recommended removing the OS2 and POSIX subsystems if they weren't needed. This meant deleting their files from System32 and the DLL cache and clearing the entries from the Session Manager registry. The main issue was not that attackers were already using these components. The goal was to reduce the attack surface by removing old and unused code from the systems where it wasn't needed. Windows 2000 was the last Microsoft operating system to include the original OS2 subsystem. Windows XP no longer had it. By 2000, many US government agencies relied on big Unix systems to handle finance, logistics, personnel and scientific information. For example, the US Army Corps of Engineers used the Financial Management System CFMS, an Oracle-based tool that tracked budget, spending, project costs and other financial tasks throughout the organization. Large applications like these could not just be rebuilt to work with Microsoft's basic POSIX support. They needed networking, database tools, command line shells and other Unix features that Windows NT didn't include at the time. So while Microsoft's first POSIX version met the government requirements, it did not give developers a practical way to move full Unix business applications to Windows NT. To make this work, Microsoft would have to provide much broader support. Software Systems saw the need for a practical solution and built a more complete Unix environment for Windows NT. The product was first called OpenNT, then renamed Interix. It did more than just meet the POSIX 0.1 standard, it gave users the tools to port and run real Unix software. Interix included hundreds of familiar Unix commands and utilities plus shells, job control, Berkeley sockets and X11 support. This allowed much more complex software to run on Windows NT than the original POSIX subsystem could ever handle. Applications were recompiled for Interix and communicated with NT's underlying services without first being translated into Win32 applications. This was not standard emulation. Unix programs still relied on the Windows NT kernel, memory manager, security and RICE drivers, but they ran in the real Unix-style environment built on top of NT. Microsoft saw the value in this technology and bought Software Systems' Interix assets in 1999. Interix later became the base for Microsoft's more advanced subsystem for Unix-based applications. Windows NT's environmental subsystems had a major impact. Cutler's team designed NT so the operating system was not tied to one application interface. Win32 became the main interface, but the architecture stayed flexible and could support other environments on the same NT base. Over 20 years later, the same idea returned to the first Windows subsystem for Linux, now called WSL1. WSL1 did not run a Linux kernel or use a conventional virtual machine, instead created special Pico processes which allowed unmodified Linux ELF binaries to run directly on Windows. Kernel mode components including lxss.sys and lxcore.sys received Linux system calls and either translated them into equivalent NT operations or implemented the required behavior themselves. WSL1 was not just a return to the old POSIX subsystem, its implementation was much more advanced. Still, the main idea was the same. Applications built for another operating system could use the Windows NT kernel without being converted to Win32. The original OS2 and POSIX subsystems were eventually removed, but their core idea remained. Windows was still just one of the environments the NT architecture could provide. The OS2 and POSIX subsystems in Windows NT were not just historical footnotes. They showed that NT was built as a flexible foundation for operating systems, not just as a bigger version of Windows. OS2 compatibility linked NT to the future that Microsoft and IBM once imagined. POSIX supported open doors for Microsoft in government and Unix-heavy markets. Both subsystems had their limits, but were eventually left behind. But the architecture that enabled them remained. The same idea would show up again in technologies like Interix and the Windows Subsystem for Linux, where application environments shared the operating system underneath. In the end, Windows NT outlasted OS2, Microsoft's first POSIX environment, and several of the processor architectures it once supported. That might be its greatest achievement. NT was built for a future no one could see, and more than 30 years later, we're still relying on the foundation Dave Cutler and his team put in place.